Hi guys, today we are going to be going over a few dosage calculation practice questions. I have about 5 for you all, and we will be working through some of these problems together. So let's begin with question number 1. So this question states, a nurse is preparing to administer simvastatin 250 milligrams IM. Available is simvastatin powder 500 milligram vial. The nurse reconstitutes the powder by adding 2 milliliters of sterile water to yield a final concentration of simvastatin 225 milligrams per milliliter. How many milliliters should the nurse administer? Round to the nearest tenth. So, there's a lot of information in this question. So let's point out some of the things that we really need to know and how we can kind of get rid of some extra fluff, if you will. So, what are we giving? We're giving simvastatin 250 milligrams IM. This is going to be through an intramuscular injection. Simvastatin is a drug typically given IM to help with diarrhea. It's very commonly used in patients who have certain types of cancer or are undergoing chemotherapy. So, available is a 500 milligram vial. The nurse reconstitutes the powder by adding 2 milliliters of sterile water to yield a final concentration of simvastatin 225 milligrams per milliliter. So, this whole piece of wording in between these two highlighted points is really not pertinent because we have our final concentration and what we need to administer. So, what do we need? Let's write that down. We need 250 milligrams, but we don't know how many milliliters that is. So we'll put a question mark for the milliliters. Now what do we have? What we have is 225 milligrams in 1 milliliter. So how many milliliters do we need to administer? So, what can we do? We have need versus have. Well, what we can do is let's put them side by side and let's cross multiply. So, let's talk about what we have, which is going to be 225 milligrams in 1 milliliter. And that is going to be equivalent to 250 milligrams with an unknown milliliter. So, how are we going to figure out this unknown milliliter? Well, let's go ahead and we're going to cross multiply, okay? We can do this because these units end up both giving us milligrams per milliliter. So let's do 225 times our unknown. So that is going to give us 225 milligrams per unknown milliliter. And that's going to be equivalent to 250 milligrams. You multiply that by 1. What is that? 250 milligrams per milliliter. How do we get this unknown by itself? We are going to divide, let me change the color. We're going to go ahead and divide 250 divided by 225 milligrams. This is going to allow our milligrams to go ahead and cancel out. So we're left with milliliters. So our unknown milliliter is going to be equivalent to 250 divided by 225. This gives us approximately 1.1, and our milligrams canceled out. We're left with milliliters. So if we round to the nearest tenth, it's already rounded, we have a 1.1 milliliters. That is how much we are going to draw up in our vial, okay? So, a lot of information, but our answer is 1.1 milliliters. Let's work on another one. A nurse is preparing to administer epinephrine to a patient having severe allergic reaction. She is ordered to administer 0.2 milligrams per kilogram IM to a client who weighs 84 pounds. Available is epinephrine, 20 milligrams per milliliters. How many milliliters should the nurse administer? Round to the nearest hundredth. So, whenever you have these questions, I always advise getting our conversions taken care of first. But let's identify what the question's asking us. So we are giving epinephrine at a rate of 0.2 milligrams per kilogram IM. Our patient's 84 pounds. What we have available is epinephrine, 20 milligrams per milliliter. So the first thing I would advise doing is go ahead and convert your pounds to your milligrams, your pounds to your kilograms. So remember the conversion. 1 kilogram is the equivalent of 2.2 pounds. So if my patient is 84 pounds, how many kilograms is that? Well, what we do is we're just going to divide 84 by 2.2. That way our pounds will go ahead cancel out, just like that. So we are left, after dividing, we are left with 38.18 kilograms. Excellent. So we've got that taken care of. Again, I just really like to get our conversions out of the way. So that is going to be step 1. Now, let's go to step number 2. I always like to write what we have versus what we need. So, step 2. What do we have available? We have 20 milligram per milliliter of epinephrine. We need to administer 0.2 milligrams per kilogram. So, how are we going to find out how much we need to administer? Well, it's per kilogram. How many kilograms does our patient weigh? Our patient weighs 38.18 kilograms. So we're going to go ahead and plug that into the equation. So we now have 0.2 milligrams, and you're going to multiply that now by 38.18 because that's how many kilograms our patient weighs. Once we do that, we are left with approximately 7.6 milligrams. So this is what my patient needs. So they now need 7.6 milligrams, okay? So we're gonna go ahead and star this. That's what we need, okay? So, what did we do for the last question? We now take our need and make that equivalent to what we have. So, step 3, we take what we have, which is 20 milligrams in 1 ml. That's what it means per milliliter, 1 milliliter, and we make that equivalent to what we need. So what we need is 7.6 milligrams. How do we know what we're trying to find out? Well, if we look all the way back up to the top of the question, it's asking how many milliliters we should administer. So we're going to go ahead and make that our unknown. So we have our unknown milliliters, okay? Now we can do our fun little cross multiply where we multiply these two and make that equivalent to these two, okay? So we multiply, but I will write it out for you. So we have our 20 milligrams times our unknown milliliter is equivalent to 7.6 milligrams times 1 milliliter. So that's going to give us 20 milligrams unknown milliliter being equivalent to 7.6 milligrams. How do we get milliliters alone? We're going to divide 7.6 over 20. Our milligrams cancel out. We are left with milliliters. So our unknown milliliter is going to be 0.38 our third question. This question states, a nurse is preparing to administer D5 to a pre-op diabetic patient. She is set to infuse 2 liters over 16 hours. The drop factor of the manual IV tubing is 10 drops per milliliter. That's what GGT stands for. It stands for drops. The nurse should set the manual IV infusion to deliver how many drops per minute? Round to the nearest whole number. So, there's a lot going on. Let's provide a bit of background information. So, on your normal IV pump, you can program it to milliliters per hour, but sometimes a pump might not be available or a pump might not be working at the moment, and you just need to calculate it yourself. We can actually calculate how many drops go into the upper chamber and calculate that as drops per minute. So there's plenty of different ways a patient can get IV fluids even if you don't have an automatic pump. So let's see what this question's asking us. I need to infuse 2 liters of this D5 solution over 16 hours. The drop factor gives me 10 drops per milliliter. So every milliliter of fluid contains about 10 drops. And what do I have to deliver? I need to find out how many drops of D5 I'm giving my patient per minute. So let's start. My first step is always going to be conversion. This helps make things a little bit easier to work with. So step 1, we're going to convert. So let's go down the line. I see 2 liters, and now I see a milliliter. So I need to change 2 liters to milliliters. So what do I need to convert? I need to convert liters to milliliters. What else do I need to convert? I'm going to also need to convert hours to minutes. Additionally, I see drops, but we'll cross that bridge when we get there. So let's do our liters. Remember, 1 liter is 1,000 milliliters. So if I have 2 liters, I need to multiply that by 1,000 to get me milliliters. That's approximately 2,000 milliliters being infused over 16 hours. Now, I know you might want to jump to converting hours to minutes, but let's hold off on that for now, okay? So for this one, we're actually going to wait to do that, okay? And I'll explain why. So I have milliliters per hour. I can easily get from hours to minutes a little bit later. Let's focus on drops, okay? Because I need, in my final answer, I need drops per minute. So let's work on the drops. Remember, what do I have? I have 10 drops in 1 milliliter. How many milliliters do I have? I have 2,000. So let's multiply 10 by 2,000. This is going to give us 20,000 drops, okay? Make sense? We had drops, we had milliliters, gives me drops. So now this question looks a little bit prettier, which brings us to step 2. I now have 20,000 drops being infused over 16 hours. So I have my drops. Now I can convert my hours to minutes. So now we can do hours to minutes. So this is when we do a little bit of converting. So we have 16 hours and I need minutes. So I need to make them cancel out. So up top we have hours. And how many minutes are in an hour? 60. And would you look at that? They cancel out. Hours, hours. I am left with 20,000 drops over, forgot, right there, minute. So I have, and then we go straight across. So we have 20,000 drops because 20,000 times 1 is 20,000 over 16 times 60 minutes. So that gets us 20,000 drops over 960 minutes. So how do I get this to drops per minute? I simply just divide. So now, after dividing, I am left with 20,000 over 960 gives me 20.8 drops per minute. What did the question ask me? It asked me to round to the nearest whole number. This gives me approximately 21 drops per minute. And that's going to be our final answer. I always like to get my conversions right before going. We could have calculated hours per minute earlier, but it is a lot easier to make sure that these line up. Especially, I had to convert milliliters to drops first as well. Okay, that was step 1. So step 1 of this, we need to somehow get liters to milliliters to drops. Then in step 2, that's when we did our hours to minutes. All right, guys, time for our last question. So, a nurse is preparing to administer 9% sodium chloride in 500 milliliters IV to infuse over 2 hours. The drop factor on the manual tubing is 10 drops per milliliter. The nurse should set the manual IV to deliver how many drops per minute. So, whenever you see a question with these drops and you're supposed to calculate how many drops per minute, I want you to understand that we are going to need to convert milliliters to drops, okay? We're changing it to a different unit of measurement. And we know that we can do that because it gives us the drop factor right here. There's 10 drops in 1 milliliter. So, step 1, like I always say, is convert. So, we're going to somehow need to convert milliliters to drops. But let's continue with the question. We also have 2 hours, but the answer is asking us for minutes. So we're going to need to calculate or convert 2 hours into minutes. So 2 hours, again, do our basic conversion. 1 hour is 60 minutes. All we did was multiply 2 times 60. That gives us 120 minutes. So, let's see what I have. My new question is I have 500 milliliters in 120 minutes. That's what I'm infusing. I'm infusing 500 milliliters of NaCl in 120 minutes. So how do I calculate that into drops per minute? So we need to take a peek at our milliliters. So remember, there are 10 drops in 1 ml. So I need to multiply 10 times 500. This gives us a pretty big number. This gives us 5,000 drops. So that's our total amount of drops we have in this 500 milliliter solution. So, step 3, simplify. I have 5,000 drops being infused over 120 minutes. But the question is asking me per minute. So I simply need to divide my top number by my bottom number. This gives me 5,000 over 120, which gives me approximately 41.6. The question asked, round to the nearest whole number. So remember, 0 through 4, hit the floor, 5 through 9, climb the vine. This is going to give me approximately 42 drops per minute. I wish you all the best of luck on your dosage calculation exams. Please remember to review your conversions such as milliliters, tablespoons, teaspoons, micrograms, kilograms, all the sorts. Also, review your 5 rights of safe medication administration.